In this video, I'm going to use the alternating series test to determine whether this series converges. Let me go ahead and rewrite this series by observing this. Look, cosine n pi is nothing but cosine of pi, cosine of 2 pi, and so on and so forth, right? So it goes between -1 and +1. So we can rewrite the series as summation n is equal to 1 to infinity, okay, cosine of n pi over square root of n is going to be equal to summation n is equal to 1 to infinity -1 to the power n over square root of n. So my an is literally going to be 1 over square root of n. So limit n approaches infinity, a sub n is nothing but limit n approaches infinity 1 over square root of n, which is obviously 0. So one of the conditions is that limit n approaches infinity, an is 0. So that condition is satisfied. And for each value of n, a sub n is 1 over square root of n, which is obviously positive, right? Greater than 0. And a sub n is greater than or equal to a sub n plus 1. I just need to show that. So look, n is less than or equal to n plus 1. That statement is true. And I can say that square root of n is less than or equal to square root of n plus 1. Now if I take the reciprocal of it, what's going to happen is that this is going to flip. So 1 over square root of n is greater than or equal to 1 over square root of n plus 1, which is to say an is greater than or equal to an plus 1. We just satisfied all three conditions that are required for the alternating series test, which is an is positive, that's condition 1. Condition 2, limit n approaches infinity, a sub n is 0, which you already showed as well. So this, and the first one is this. And the third one is a sub n is greater than or equal to a sub n plus 1, which we showed right here. So all three conditions are satisfied for this series, right? Therefore, by the alternating series test, the series must converge. So it must converge. I hope that this discussion was helpful. Thank you very much.